Welcome. In this session, I'm going to discuss two examples designed to illustrate some of the basic concepts having to do with calculating revenue and profit. Basically, you just need to know some of the terminology our textbook uses. The overhead is called fixed cost. These are costs which are fixed irrespective of the production level. So this would typically include the rent, lease charges for machinery, interest on borrowing, or lost interest on capital invested, things like that. Variable costs are costs affected by the level of production. So this would be raw materials or other inputs that go into production, including energy, the cost of hourly labor, which can be adjusted up or down depending on need, and similar things. The total cost is what we get by adding these two. Revenue is the total gross income. We will calculate it typically as unit price times quantity sold, where the quantity sold will be given by the demand function. Or the unit price, depending upon which way the demand function is written. This is, of course, very simple if you think about it. If I sell 1,000 doodads at $5 each, the revenue is 5 times 1,000. And profit is revenue minus total cost. So to repeat, the main really new idea is that revenue is P times Q, or price times quantity. We'll consistently use P for unit price and Q for quantity. So let's look at some simple examples. So Acme Incorporated has fixed costs of $60,000 per month, and it costs them $35 per pair of spring-powered boots. They sell them for $75 each per pair. So the question is, how many pairs must be sold per month to realize a profit of $40,000 per month? So in this case, the demand equation is very simple. The price is fixed, P equals 75. They are not adjusting that. So let's call the quantity sold Q. Revenue will be 75Q. Sorry, 75Q. It's $75 per month. The variable costs are 60,000 for the fixed cost and 35Q. 35 times Q, the quantity number sold, assuming that they are able to match their production to the demand. So total cost will be 35Q plus 6,000. And the profit will be revenue minus cost. And we want this to be 40,000. So we set that equal to 40,000 after simplification and solve for Q. So a linear equation, so it's very simple to solve, and we get the quantity. Okay. Now let's look at a more complicated example where the demand changes with price. So a shoe store chain discovered that if they price their house sneakers at $20 per pair, they can sell 49,000 pairs every week nationwide. And for each 50-cent price increase, they would reduce the number sold by 1,000 pairs per. And we want to figure out when the revenue will be a maximum, how they should price it. So I need to start by finding the demand function first. So we have some information that Q be the quantity and P the price. Then because the demand changes at a uniform rate, this would be a linear function. And one price point they give us is at $20 per pair, they sell 49,000 pairs. Let's leave the 1,000 out. Let Q be the number in thousands of pairs. So that gives us the price point P equals 20, Q equals 49. And if they increase the price by 50 cents, then the demand goes down by 1,000. That gives us the price point 20.5, 20 plus half a 50-cent price increase. and Q equals 48, 49,000 minus 1,000. So we have to find the equation connect of the line joining these 2 points. And if you calculate the slope, we'll do Q as a function of P. The slope is -2. First, we could have done it a different way using just reasoning rather than definition of slope. And using the point slope form, we can write down the equation of the line and solve for Q to get Q as a function of P. And so now in this case, we will write the revenue in the form of a function of Q. Revenue is always P times Q. If the demand is given in the form of P equals a function of Q, then you would substitute for P, you would get revenue as a function of Q. On the other hand, like in this example, if you have Q as a function of P, then you would substitute for Q and you would get the revenue as a function of P. Basically, this is how you find revenue from the demand equation. Let's go ahead and finish this problem. Here we want the revenue to be a maximum, and since revenue is a quadratic polynomial with a negative square coefficient, this is just a vertex problem. Find the vertex and find the want as the corresponding, well, they just want the price level, but if you want the revenue, just plug that in as well. So hopefully with these 2 examples, you have a rough idea of how to calculate the revenue or profit function given the other information. I will stop this here. Bye.